Hi everyone, let's start solving today's lead code question. 1 to 9, some root to leaf numbers. Let's try to understand the question first. We are given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. For example, the root to leaf path 1, 2, 3 represent the number 1, 2, 3. Okay. Return the total sum of all the root to leaf numbers. Test case are generated so that the answer will fit in a 32-bit integer. Okay. That is fine. So this question is basically saying if I'm traversing from root to any leaf node, so these numbers are representing. If I merge them together, it will form a number. So if I go to 1 to 2 and I am here seeing 2 is a leaf node, so it will generate a number 1 2 as it is shown here. And if I reach here to this leaf node, I will generate a number 1 3. If I to add this up, it will give me 25. Okay. This question is very simple if you ever traversed a binary tree before. If you never did that question before, that is no worries. We will see in that question as well. But if you ever solved a question where you traverse the tree, this question is looking as simple as that question. Okay. So what are the observations? Observations of this question is nothing. I need to traverse the tree to generate the number, traverse the whole tree. Okay. I do not take to care any mode operations or something because the answer will generate no mode required. Okay. What is the third observation? At the time I reached, at the time I reach a leaf node, my number should get generated. Okay. So these are the three observations. These things I need to implement and after one number got generated, I will go to the next sub problem and I will generate the next number and I will add that particular number into previous number. Okay, let's try to take an example first. Okay, this example we just seen. So if I am standing at root, so I there is one, and if I go here, uh, I will merge in my first number which is one, and this became I went to one more node, this became 2. Now my 2 became leaf node, so I do not have to generate any other now. Now the result of this number should be added into some another number. Okay, then I came back to 1. Okay, this will give me nothing but 12. Okay, now I go into right direction. Okay, this will give me 1 and 3. Now it will return me 1 3. Now I need to plus all this 25. As I'm seeing, like here I'm doing I sold this first, then I sold this first. Okay, so I am feeling a recursion here. Okay, now one more thing I observed. I processed the root node first. I processed the root node first, then I went in the left direction, then I went into the right direction, which is nothing but pre-order traversal. Okay, anything other I am traversing. So okay, if in this example it is not visible, we'll try to solve another example. Okay, we need to observe everything. Okay, I stand at the root, I went there for 9. Does the it is a leaf node? No, I went into left direction more. It is a leaf node, so it will give me 495. Okay, till here I got 495. I go in this direction now. Okay, so this is a leaf node as well, so it will give me 491. Okay, it got returned with 491. Okay, it will return addition of both the numbers 495 plus 491. Okay, now I will go in this direction. This direction here, this is a leaf node, so this will 40. Now I will add up all these things. Okay, so 495, 491 plus 40, which will give me 6, 9 and 9 18, 18 and 4 22, 2. Okay, 41026. Okay, I just simply added all these numbers. Okay, so 1026 is the answer. So what I am observed here is, so the traversal is fixed. Okay, I am doing the pre-order traversal. Okay, traversal I know, with traversal I am doing. Okay, recursion I know, like I will solve this problem using recursion only. लेकिन एक और thing यहाँ पे missing है कि मैं किस type से recursion call करूँगा. This is nothing but DFS, which is known as depth first search. So what is depth first search? I am solving first the left all the sub problems. After solving all the left of the sub problems, I am going to write sub problems. Then I'm giving a call back to the parent function. Then I'm going to the right sub problem. Okay. So what I how I approach this question first? I try to do a naive approach. I created a list here. Okay. Let me give you a, a walkthrough to the code. What I did, I created a data structure to store all the numbers. Okay. So data structure I used here is list only. Okay. So if root is null, I will return 0. I just simply did a DFS. Okay. I created a temp variable. So this is the base case for root, for leaf node, sorry. Okay. So what is the definition of a leaf node? A leaf node where the left subchild is also null and the right subchild is also null. So this node is known as leaf node. So basically this only I written in my code. So root dot left is equal to null, or root dot right is equal to null. So उस टाइम पे मैं क्या करूँगा, जो भी मेरी वैल है, वैल जो मैं पैरामीटर में एक्सेप्ट किया था, उस वैल्यू को मैं 10 से मल्टीप्लाई करूँगा, प्लस में जो भी वैल्यू होगी उसको ऐड कर दूंगा. ये बेसिकली मैं टेम्प के अंदर कर रहा हूँ. ओके. सो वेल के जैसे कि अब मैं 1 था, 1 से 2 पे आया. ओके. 1 से 2 पे आया तो ये लीफ नोड है 2. ओके. सो ये मेरा उसमें आया था वेल में. ओके. सो टेम्प से मैंने क्या जनरेट करा, टेम्प इज इक्वल टू 1 into 10 plus 2, which is giving me 12. Okay. So when I reach the leaf node, I am adding that particular number. I am adding that particular temp into my list. Okay. Okay. Then what if, like in the above example, let's suppose this is the example 1, 2, 3, 4. Okay. So I reached here. Then I need to come to this sub problem. Okay. I started. Let me try to take some another. So I was here. Well, I need to calculate well here in this case. Okay. Okay, well was 0. So I came here. This is not a leaf node. So I came here. Now temp will become 0 into 10 plus 1. So at this case, at this point, temp will become 1. Okay, now I came to this. Okay, now this is not a leaf node. So what temp will become 1 into 10 plus 2. Here temp will become 12. Okay, this is not a leaf node. I still go in the left direction. Now temp will become, this is a leaf node. Okay, now for I go inside this condition, and what I will do, 1 2 into 10 plus 3. Okay, so now the temp will become 1 2 3. Okay, now 1 2 3 I am heading here in the list. Okay, now I go back. Now here, if I go back, the temp value, the value which I am accepting in the parameter, will be the previous one. So value here will be 1 2 only. Now I will go in this 1 2. Now I will generate, because this is the leaf node. So temp is equal to 1 2 into 10 plus 4. So that is 1 2 4. Okay. Here I am going, before going into left child or right child, I am checking here an if condition. Okay. Then I am doing the DFS on it. Okay. At the end, I am traversing the whole list, and I'm returning the sum of it. So you now some of the viewers have a question in their mind ki why this person is using an extra data structure to store the numbers. If we are solving this recursively, this question recursively, why we cannot use the same answer of the previous function call and add up it. Okay, so let's try to optimize. Okay, so here the time complexity will be order of n because we are trying to iterate all the elements. Now if I talk about the space complexity is nothing but all the so how many leaf nodes are there, and that is my space complexity, because at every leaf node I am adding a value into my list. Okay, so that is my space complexity. So okay, and I if I know how many leaf node can in the worst case can be present in a binary tree, so that is 2 raised to power n minus 1. Okay, because where n is the level, let me take another value, 2 raised to power height minus 1. Okay, so this is the space complexity. Okay, so if I try to optimize the space complexity now, let's try to understand from this question only. Okay, I started at the root node. I went into this subproblem 9. This is not a leaf node. I went it again. This is a leaf node. Okay, so till here I generated 495. Now if this subproblem, the whole subproblem is completed, do I need to come again to this subproblem? Never. So what I can do, the whole result I can add up into this subproblem. Okay, so this will become, if I now came here in this direction, it will become 491. I will simply at this stage only I am adding this up. So 495 plus 491, 6, 18 and 6. Okay, sorry, 986. So what I will return from here is nothing but 986, and 986 I will add up here. Okay, in this result of this question. So if I come in this, it will give me 40. So at 986 I will add 40 here only. So there is no need to store the numbers. I can simply add it after solving every सब प्रॉब्लम. हर एक लीफ नोड आने के बाद मैं एक वैल्यू जनरेट करूंगा, उस वैल्यू को अपने सम में प्लस करता जाऊंगा, उस सम में प्लस करने के बाद मैं दूसरी सब प्रॉब्लम पे जाऊंगा उसको सोल्व करके, और एट दैट पर्टिकुलर टाइम ओनली व्हेन आई रीच द लीफ नोड उसी टाइम ऐड कर दूंगा. ओके, 021026, that's the answer. Okay, let's try to see the code of the optimized space complexity. So simply I am returning the DFS, okay, where my current sum is 0 and I am sending root here. Okay, if root is null I will simply return 0 here. I created a temp variable. Okay, this is the case of a leaf node. Okay, now at every if I reaching any sub problem in the left direction or either right direction, before I reached the leaf node I need to modify my temp variable, because to generate the number I need to multiply it by 10 and add the root value in it. Now at the end what I can return, DFS from the left sub problem plus the answer I got from the left subtree plus the answer of I get from right subtree. Okay, so here I am not using explicitly an extra space complexity. So time complexity will remain same, order of n, where n is the all nodes of the tree. Space complexity I am not using any extra space, but there are recursive calls. Recursive call it will be order of h. Okay, so that will be order of h, where h is the height of the tree, because I will reach here only now. Maximum my recursive stacks can store how many function calls, the height of the tree, because after reaching a leaf node I am going back. Okay, this is height of the binary tree. So I think the time complexity and space complexity also clear of this question. So if this video helped you, please like and subscribe to this channel. Thank you.